Hi, welcome back to Future Fast. And once again, we have Dr. Adrian with us. And for those of you who are not familiar, I really urge you to look up to the two parts of our podcast that we've had with Dr. Adrian. And first part is about his journey, and second part is where he talks about the a whole lot of talk about oil and energy in general. So you don't want to miss it when you want to be part of this conversation. So please go there. And for those of you who have not yet subscribed, this is the time to subscribe to Future Fast. And for the rest of you, thank you for being part of our ride and enjoy our conversation. Adrian, welcome back to Future Fast, and thank you so much for making time to be here with us.
Thank you very much. It's a pleasure to be with you and your listeners again. It's a pleasure.
Wonderful. So, Adrian, diving straight into the conversation, what is your perspective on the future in general?
Well, I think future is always interesting. It for sure has a number of significant challenges that we need to overcome, especially on the energy front. We are looking at solving the most complex problem that humanity had to overcome in our history, which is solving for the energy trilemma, making sure that as a society we're capable of providing enough energy to power our economy and our needs, but at the same time making sure that energy is affordable, so we produce it in a way that allows people to use it and our society to consume it without hampering our production of goods and services, and also produce it in a sustainable manner. So this is the fundamental challenge that we have to deal with, and it's extremely complex, and there is no, unfortunately, as we are speaking now, there is no easy fix for it. We're trying, and we see policy making going for easy fixes, but the future is nothing but an easy fix. Lots of people are saying, well, the future is electric. Electricity is a very elegant energy form, and surely the distant future is electric. But to get to that completely electric future, we need to solve a number of technological challenges for which, unfortunately, as of today, we don't have an adequate answer. We have partial answers. Like, for example, for mobility, we have electric mobility as a potential solution, but it's not a complete solution. And I was mentioning in our earlier conversation that when we're looking at the energy solution for the world, wherever we look, we see limitations, either of raw materials that are required for the energy transition or limitations of technology. There are limitations of all sorts of kinds, whichever way we look. There is no such thing as this is the solution. So the future, rather than being electric, I believe the not so distant future is going to be eclectic. It will be a combination of things that are stemming from this inability to find the 100% correct solution. We're having partial solution to a very complex equation. So going back to your question about where I see the future of oil and gas, we mentioned earlier that fossil fuels stand for about 70% of all the energy production of today, and they are irreplaceable as raw materials for the myriad of materials and applications that are powering and that are populating our daily life. So even if we are going to replace fossil fuels as a fuel, as a source of energy completely, we cannot replace them for the myriads of other materials that are required for our society. So the perfect future would be one where all the combustion has been replaced by nuclear and renewable energy. And all the fossil fuel resources are allocated for producing the raw materials that are required for the petrochemical and the chemical industries. Because even if we are capable of ensuring propulsion and mobility with using electricity, we're not going to be able to replace these substances, these materials, as feedstocks to produce everything that is required by a modern society.
What about renewables?
Renewable energy is very useful in itself. We see currently a few challenges that relate to renewable energy. The first one is that producing electricity through intermittent sources is curtailed by our ability to use that electricity on demand rather than when the sun shines or when the wind blows. Other sources of renewable energy, like hydropower, which is arguably the cheapest and the most useful type of power we have at our disposal because it's cheap, it doesn't produce any carbon dioxide emissions, and
perhaps
it's
the most sustainable source.
It's the most sustainable source, and it's extremely dispatchable. You know, it takes on average 30 seconds to start a water turbine that's part of a water power plant, a hydropower plant, and that turbines will spin directly a generator. So you have electricity on demand, and you can ramp it up and down as you wish, without a significant decrease in the yield of that particular turbine spinning a generator to produce power. But the scaling up of hydropower is not that feasible simply because most of the, it depends on geography and depends on specificity, soil, and forms of to be able to build the dams that are required to have power plants. So most of the hydro capacity that was available, especially in the developed world and in China, has already been put into production. So we are going back to renewable energy being mainly solar power and wind power.
How do you see the energy generated out of waves? I think Google is able to power and even have their cloud infrastructure on the sea powered by tidal energy. So do you see that from any point of scalability? Because we have such a vast ocean area, 3/4 of the earth is ocean. So do you see a scope for tidal energy to be a reliable source of energy?
Tidal energy is definitely there. There are two major problems with tidal energy. It requires a massive infrastructure development, and you have a very narrow band around the world where the tide is significant enough to produce power. To produce power, you need a tide that's at least 8 meters high. And you have a very, very narrow band around the world where that kind of tide is feasible. We have I think it was the first tidal power plant in the world, which was built on the western coast of France, where we have the equinox tides are 11.5 meters. So that's a very suitable place for installing a tidal power plant. But the marine environment is not very suitable for such applications. Salt water and rotating equipment, they never make for a good relationship. And again, the scaling up is limited to geography, and it's also limited by the cost of setting it up and the cost of maintenance.
Okay. What about hydrogen?
Hydrogen is not an energy source. Hydrogen is just it's a component of our universe. The problem is that for hydrogen to be useful, it needs to be produced. It has this annoying trait of not being found by itself. It's you find hydrogen, linked to an oxygen atom, and that's water. So it needs to be produced from water, and the electrolysis of water, which is the way we are producing most of the hydrogen. Well, actually, no, that is incorrect.
From
That
ammonia,
hydrogen. Water electrolysis is the way to produce hydrogen with a lower carbon footprint, because ideally, if you use electricity that's coming from renewable energy, from a solar farm or from a wind farm, then that electricity doesn't come with a carbon emission attached to it. And because there is no carbon emission, you can produce, using that electricity, you do water electrolysis, and you produce hydrogen that is cleaner. It's the sort of the blue hydrogen that everybody is talking about. The problem is that, one, the yield of electrolysis is not great. It consumes a lot of electricity. And we are back to square one, because the fundamental problem of our world today is that we are not capable of producing enough electricity to power the current needs, let alone additional needs that would come from a hydrogen economy. So as of today, the most useful way of producing hydrogen is what we are using in the oil industry, in the refining business, and in the petrochemical industry. And this is a high yield kind of process, and we're producing hydrogen through the methane steam reforming. So we basically take methane gas and we chuck it into a reactor, and under temperature and pressure, it breaks the molecular bond between the hydrogen and the carbon atoms, and you end up with a purified stream of hydrogen. And this is the traditional way of making hydrogen. And today, probably 99% of the hydrogen that's produced in the world is produced through steam reforming of methane gas. So hydrogen
storage is a problem, transportation is a problem. So
everything is a problem when we're talking about hydrogen.
But how are these people like Toyota talking about future of fuel is hydrogen, and they're betting so big, and other automobile companies are also talking about it. So, and I think Germany is, I mean, the project is delayed, but they're talking about a hydrogen-powered railway network. So
yes, they do. But again, lots of people are talking about lots of things, and everybody's trying to take one potential solution and herald it as the solution to the energy conundrum. So going back to propulsion based on hydrogen, why are people looking into it? Well, they're looking into it simply because the propulsion based on electric batteries is facing shortages of raw materials, especially if we're talking about electric propulsion based on electricity stored on board in batteries, using the lithium ion chemistry of today, which is the type of battery that enjoys the highest energy density of all types of batteries that we're having at our disposal. And for mobile applications, the energy density and the cost are the main important factors. So you have to go with the lithium ion chemistry development avenue of sorts. But if you go that way, which is what Tesla is banking on, there is a big question mark on the sustainability of this avenue on the long term. And the long term means what happens 40, 50 years from now. And if we carefully look into what happens in 40 or 50 years from now, we see that there are significant question marks on the availability of the key raw materials. So, I'm an engineer by training, and I like numbers. So let's look, briefly for your auditors and our auditors as of today. Let's look at what happens in the case of a Tesla battery, which is the golden standard for electric car propulsion as of today, right? So a Tesla battery is about 500 kilograms of weight. That's the size of a Tesla battery, and it's composed of 16 different modules, and each module is composed of a number of individual cells. So the individual cell for a Tesla battery is a small cylinder that's probably not more than 7 centimeters tall and probably 2 centimeters in diameter. And that's the essence of this battery. And then you have 7,000 individual cells that are linked in series and in parallel, and they are making for this excellent battery that has the capacity of powering a vehicle for hundreds of kilometers, right? Now, if we're looking at what are the raw materials that are required for the production of this battery, which is the heart of the whole thing, because, one of the advantages of electric cars is the simplicity of the whole thing. The engine, which is the most complex element of a traditional car, the internal combustion engine, is replaced by a battery and 2 electric motors that are actuating the wheels. From a mechanical standpoint, it's a much simpler contraption compared to the standard internal combustion engine. So if we're looking at this kind of battery, the battery uses a number of raw materials, and it uses a lot of nickel and a lot of lithium, and it uses some cobalt. Now, nickel, and it uses aluminum as well. Nickel and aluminum, they're not problematic materials necessarily, because we consider them to be relatively abundant in the Earth's crust. So that's not an issue to source them. The problems are related to lithium and cobalt. And the problems are fairly different. Lithium, we have lithium reserves that have been pretty well cataloged, and there has been a significant surge in the lithium discoveries last year, 2022. So the lithium reserves went up from about 11 million metric tons in 2022. So a total of about 26 million metric tons, but out of which 11 million tons are grouped in the traditional lithium exporting countries, which are Chile, Australia, Argentina, and China. So these were the traditional.
India found 2 sources.
Yes. These 4 were the traditional sources, right? Chile, Australia, Argentina, and China. And now, with the discoveries that have been made throughout 2022, we are up to about 98 million metric tons. And basically, the biggest discoveries have been in Bolivia and Argentina and US. These are the areas where a lot of new lithium deposits have been discovered. It doesn't mean that all of them are equally easily exploitable compared to the traditional deposits in Chile and Australia, but there are deposits nevertheless. So let's say 100 million metric tons of lithium. And if we are looking at how much lithium an average Tesla car is using, you know, and we assume, let's say, 100 million electric vehicles that are manufactured every year, which is typically what we are referring to when we are looking at the production and the future trend of motor vehicle production. You know, we've been before the COVID pandemic, we were at about 97, 98 million vehicles per unit per year. So in, you know, going forward in the future, we can assume 100, 110 million vehicles will be produced. So assuming that, and you know, making another assumption here just to put things into perspective, let's say we want the car park, the entire car park, so this 100 million vehicles per year, let's say we want 50% of it to be electrified by 2040, and we want by 2075 to have 75% of the car park worldwide on electric propulsion based on lithium-ion batteries. Well, reserves are not going to last very long. And the reserves typically will last for less than 35 years. If we are to get the car park that's put forward here, 105, 110 million vehicles, and we want 50% and 75%, the reserves of lithium, these 98 million metric tons, will not last for more than 35 to 40 years. So
but
that makes...
Lithium from the batteries can be recovered to almost 100%, right? So they will bring in a circular supply, right, in that sense?
It's really problematic. Recycling lithium, it's really problematic. We can recycle, without doubt, the nickel and the cobalt, but recycling lithium is a major problem. So we're not successful as of today to recycle lithium from the lithium.
What I read was they said 98% can be recycled, but we can achieve 100% recycling is what the report said. So I was just wondering, that makes it cheesy, no?
Well, I am yet to see a lithium recycling, lithium-ion battery recycling plant that works and has an economical, feasible technology to recycle lithium.
Oh, I believe China has 2 plants. That's what I read, but you're the best person to comment on that. I
haven't seen. It's like the solid state battery that's touted by Toyota. Yeah, we keep hearing about it, but in reality, we don't have it operational yet. So obviously, if that can be achieved, it's a matter of cost. At what cost the reprocessing of lithium can be brought to the market, and because one of the other fundamental elements of electric propulsion is the cost per kilometer, and it's, for now, I'm not aware of any successful recycling technology.
So do you see viable. In future we will have railways powered by nuclear power?
No, I don't think so. I think nuclear power is, in essence, a baseload electricity provider. And I see electric railways, which is the easiest way to do rail transportation. Because for railways, the fundamental complication is to have the rail installed in the first instance, is not to put an electric network, an electric grid that's siding the railway. It's the construction that is required to set the rail on the ground that's extremely complicated. But you know, if you look at rail transportation in Europe, France is having by far the best electric rail, high-speed rail network in the world, I think now China is having the biggest network, of course, but I still think the rail network in France works better than the one in China, and all that propulsion is electric. So this is a major.
France also has the hydrogen powered railway, some
No,
patch?
no, we don't.
No?
In France, we have only electric powered.
But then how is it
locomotives.
Alstom is going about setting up? I think they got a project even in UK for hydrogen powered. So I thought maybe because Alstom is a French company, so they have something there.
They are building hydrogen powered engines as demonstrators, because obviously hydrogen is one of the elements that's very much liked by policymakers and the public, especially in Europe. And there is a lot of funding that's behind pushing hydrogen initiatives every which way. It doesn't necessarily mean that they are better alternatives. When you look at hydrogen, when you talk about hydrogen, there are two ways of utilizing hydrogen. There is one which calls for hydrogen to be burned in internal combustion engines instead of gasoline or diesel. And we know how to do that. It's a fairly straightforward way of producing work, because it uses internal combustion engines. We're pretty good at making those. The technology is very mature, and you don't have to change an awful lot of things.
The problem with that is the leakage of hydrogen is very high, right? Almost 30% is
30% is what you tend. Well, it depends on the distance of transporting hydrogen and on the way you store. Hydrogen is the smallest molecule in the universe, right? As such, is very difficult to be contained, especially under pressure in a reservoir, because all the materials that we can make reservoirs of will have a porosity in their grain, in their material, that will not stop the hydrogen molecules from going through, which is why we are encountering hydrogen leaks, because of this permeability to hydrogen when we are looking at transporting hydrogen in pipelines. The other problem is that transporting hydrogen makes steel brittle under certain circumstances. So if we want to store liquid hydrogen, for example, which is the way to store it, because if you store it as a gas, it takes much more volume, even when you compress it. So it makes sense to compress it to the point you liquefy it and you store it as a liquid. But that makes steel and steel alloys brittle. So when you transport hydrogen in a refinery, we transport it on very short distances as a gas, right? We transport it from the hydrogen generation plant to a storage tank, which is a few hundred meters far. We're not transporting hydrogen over tens of kilometers or hundreds of kilometers or thousands of kilometers, which is one of the projects we are having in Europe to build a hydrogen transport network, bringing hydrogen from North Africa to Western Europe, which calls for a 2,000, 3,000 kilometer long hydrogen pipeline network. And the other problem is that using hydrogen is not necessarily that safe. You have to take special precautions to use hydrogen, both to store it and to use it. And as I said, you can use hydrogen in two different ways. You can burn it in an internal combustion engine, or you can oxidize hydrogen in a hydrogen fuel cell. So you put the hydrogen fuel cell, you put hydrogen gas through a hydrogen fuel cell, you oxidize it, and it produces electricity, and you have water as a byproduct.
What is the complexity involved in the oxidization of that through fuel cell? Because that seems to be still, people are still talking, but nothing really coming into the market, right? From a point of utility?
No, yeah, you have a number of companies who are actually manufacturing hydrogen powered cars that are using fuel cells. But the major problem with that is the very low yield of the entire operation. So basically, you start with electricity that we have to make it. You make electricity to do water electrolysis, to produce hydrogen, to oxidize it in a fuel cell, to produce electricity, to spin motors, right? So you go full circle to using electricity in electric motors. And the only reason people are looking at this alternative is the sustainability of electric batteries as the storage solution based on lithium-ion chemistry as a storage solution for electric propulsion, which is hampered by what we just discussed.
Yeah, even BMW, I think, sold only 400 cars over last 8 years, the hydrogen cell-powered car.
Yes. It's it's not the more popular version out there. But at the same time, in a world where you have electricity in abundance, electricity is everywhere and it's cheap, you can conceptually think about using a gas like hydrogen as an energy storage medium of sorts, because you can oxidize it or you can burn it, and that would be the difference between using a gas like hydrogen as an energy storage medium compared to, let's say, carbon dioxide or compressed air. There are also people looking into this, the idea of storing energy in the form of compressed air, which doesn't make an awful lot of sense, but nevertheless, there are people who are investigating it.
Adrian, I came across this a startup in UK talking about creating hydrogen charging stations, fueling stations. But what they proposed is that they will pipe not hydrogen but ammonia.
Yes.
And at each fueling center, they will break ammonia into hydrogen so that they don't have to transport hydrogen and thereby lose a lot of hydrogen in the transit. So piping ammonia is a lot easier, which is
indeed
being done for a long time. So that way they see there will be thousands of hydrogen fuel centers, and where hydrogen is freshly generated so that loss is minimized. So what's your take on that?
Ammonia is, as you said, much more used as an energy storage medium than hydrogen, simply because it's much simpler use, and the risks that are associated with handling ammonia are significantly reduced compared to handling hydrogen as a gas. The problem is that hydrogen needs to be separated from ammonia, and that requires for a separator at each point of use. And that's not that easy to build. I mean, you require infrastructure and you require additional power, and that's the major issue here. So we were looking at such a business case, and basically you can do it, providing you have a lot of capital that you have available to invest. And then you have to look at the cost of producing hydrogen through ammonia separation on a constant basis.
If you put 2,000 fuel cell centers, so 2,000 units where you break ammonia, is that a very complex process?
It's not a complex process. I mean, but it requires infrastructure.
Right.
So it's like the reason we have big refineries, that in this line of business, the bigger the better. You can arguably say, well, I don't want to bother about transporting, let's say, kerosene or gasoline. It would be better if we just pipe oil, and at each point of use, we are going to separate the gasoline from the crude. And
so
the reason we decided,
this is how it sounds. I mean, This idea sounds similar to what you say, that funnel the crude and then separate it.
Yeah, the reason we have centralized separation activities is that in the separation business, the bigger the better, the bigger the higher the yield, and the more economical it gets for the users, for the consumers. With ammonia is the same thing. When Germany is looking, for example, at an ammonia distribution network, they're thinking about importing ammonia from the Middle East, for example. My company is the biggest producer of ammonia in the world, or from Canada, because Canada has this project that's not operational yet, which is calling for producing an awful lot of ammonia using renewable energy and then exporting that ammonia. And Germany is a prime customer simply because it's the most advanced economy that's today incapable of providing enough energy to power their needs. So they're looking at transporting ammonia through the existing gas networks, but having regional centers for separating hydrogen from ammonia. Regional centers. So they're not thinking about having the separation done at the point of sale. So, the idea is not to have like a gas station of the type we're having everywhere today, and each gas station having their own reactor and separating the hydrogen from ammonia. No.
So, okay.
It can be done, but whether that can be done in an economically sound manner, it's left very much to the imagination.
Right. So then, what do you think is the energy that we can rely upon? I mean, of course, you said nuclear, but for transport?
I think for the next 20 to 30 years, we will still have to rely on fossil fuels. I don't see anything. Yeah, I don't see renewable energy. Renewable energy and electric propulsion based on lithium-ion batteries will definitely scale up. But we're back to square one. Okay, where is that additional electricity going to come from? Because of our inability to power with, to produce enough electricity to substantiate, to satisfy today's electricity requirement, let alone additional requirements coming from all the extra electric vehicles that are going to be linked to the grid. And the other problem is that, if you just have a look at a German Autobahn, a German highway at rush hour, imagining all those vehicles that are piled up on the highway, connecting to the, some sort of feeding station, charging station, it's just unrealistic at this time. It requires an investment in electric charging infrastructure that nobody is actually contemplating in Western Europe or in the developed world. People think that the electric cars will be charged by plugging them into your socket at home, and you leave the car charging overnight. Yes, a minority of people will be doing that, but you also need fueling stations, like you need charging stations along the major transportation axes.
So, Adrian, it's time that I ask, can you please make your predictions for our audience and listeners for Future Path?
Well, the future is always brighter than the present, isn't it?
Always.
Yeah, no, I think it's a fascinating time to be alive now, because we see so much challenge and so much change and so many different avenues of change that we are contemplating. And for me, that makes it a fascinating case. I think if we're speaking specifically about the oil and gas industry, I really expect the oil and gas industry to still be the main engine of the world for the next 2 to 3 decades, for some of the reasons that we have discussed. The sheer scale of what is required to replace it, the fact that our entire civilization is completely relying upon fossil fuels, both for energy production and also for the myriads of products that are deriving from oil. From the point of view of the sustainability on the longer term of all the alternatives that we are currently having. So for all these reasons, I believe oil and gas will still be a very important factor in our energy mix. I can also see the percentage of energy coming from fossil fuels gradually declining, especially as massive nuclear capacity is coming on stream. We see a clear trend, unfortunately, in the developed world, not in Europe, not in the United States or Canada, but we see it clearly happening in India. We see it happening in China. We see it happening in the Middle East. We see it happening in a number of countries around the world where energy has never been taken for granted, which is what has happened, unfortunately, in the developed world, where energy was always abundant. If we're thinking about the last 80 years or so. So I expect the percentage of fossil fuel generated energy to gradually decline. I also expect the percentage of renewable energy coming from wind and solar to increase to the maximum that's allowed by the individual national grids that are powering our countries. And that percentage depends a lot on the structure of the national grid, of the relative degree of integration, and on the type of power that is injected in those national grids. Obviously, the more dispatchable power you have, the type either latest generation nuclear or hydropower, the more your capacity to ramp the production up and down to follow demand is going to be. Therefore, the more intermittent power you can inject in the network. In Europe, with the technology we have right now and with the energy mix we have, in Europe on average, we can go up to about a third total grid input as renewable. So there is still quite a significant space to grow the renewable share of power, but having a future that is completely powered by renewable energy at this point in time, I don't see it happening for the reasons we have discussed. I also expect the share of nuclear to grow quite substantially, especially if policymakers are getting slowly but surely convinced that there is no alternative for a feasible economic future for mankind without massive investment and massive ramping up of our nuclear capacity.
True, that also happened more so because of the war. Otherwise, I think there was a complete no nuclear kind of a thinking that was on. So even on the fuel and petroleum, most of the countries, including India, are thinking that we are hitting the dead end very soon. So what do you think will have to happen for them to change this outlook? Because they're talking about 2035, which is just 12 years from now. And you're saying at least 2 to 3 decades. So is there some concerted effort from companies such as yours in trying to educate them? Or how do you think this will come about?
No, I don't think we're making a conscious effort to educate anyone. I think the reality speaks for itself. And it's enough to look at what happens in Europe right now with the energy pricing soaring and a lot of talking about Germany's deindustrialization because of their inability to generate enough energy to power their economy, to get a pretty accurate glimpse of what's coming if we don't put pragmatism before ideology. And surely, slowly but surely, we're seeing the opinion swaying from, oh, nuclear is bad, nuclear power equals nuclear weapons, which is a major, major mistake, or nuclear power equals Chernobyl and Fukushima and 3 Mile Island, which is also false because statistically speaking, the nuclear energy has by far the safest track record of any industry out there. So it's just public perception. But for us in the oil and gas industry, no, we're not making an effort to educate people. We have a pretty stout, pretty solid stance when we talk about these sort of things, especially in the Middle East, where the leaders of the oil companies are quite pragmatic, and they have a very down to the earth attitude to the whole energy transition issue. And at the same time, we're not saying no to renewable energy, or we're not saying no to any of the avenues to produce more energy. If anything, we are some of the oil companies are pioneering new technologies and investment in renewables. And definitely Saudi Aramco and Total Energies are probably the biggest companies out there pioneering technology and investment in such fields. But we are fully aware of the dimension of this issue, because we are engineers, we are engineering companies, and we have our finger on the pulse of the global economy. We know what it takes to power the global economy, and we know policymaking and wild dreams are not going to cut it. At the same time, for example, we are pioneering technologies in the area of carbon capture, because we know for sure that we need to rein in the amount of carbon dioxide we produce for a number of reasons. Whether you're fully believing in the fact that carbon dioxide contributes to global warming and climate change, or you think, no, it's a minor contributor, but it's the only factor that we can manage. From a very personal perspective, most of the climate change is not influenced by the carbon dioxide we produce. It's influenced by the intensity of our sun's activity, which is orders of magnitude more relevant than the amount of carbon dioxide we put up in the atmosphere. But unfortunately, there is nothing we can do about solar activity, and a lot we can do about producing carbon dioxide through combustion. So we are welcoming all the breakthrough technology in carbon capture and storage. We are pioneering some of the technology that's at the cutting edge in this area, and we are pioneering investment in renewables.
Well, Adrian, I'm sure you would have faced this because every time an argument like this is made, the people who like to identify themselves with as environmentalists are those who think for the global warming case, that they tend to say that this is an argument from the people in the oil and gas industry. It's more agenda driven. So how do you handle this, or how far do you think this backlash will continue? When do you think people will say, okay, fine, let's look at what is reality? Or when will these two things meet?
It's an interesting question. You see, the problem is that, or at least from my point of view, right? From my point of view, the main issue, and I'm speaking at quite a number of events and conferences on such topics, and I can definitely say one thing. Most of the eco warriors and the green advocates have spent less time in school than Greta Thunberg. Very, very few of them are engineers. Most of them can't make the difference between a pump and a compressor and a satellite. So it's quite funny that as a specialist, as somebody who spent 30 years in this industry, and somebody who has advanced engineering degrees and business degrees and advanced business degrees, your word weighs less than the word of somebody who graduated from a high school, got an accountability degree, and all of a sudden is becoming an eco warrior. To understand these issues, you need to have, in most cases, a solid engineering degree. Energy is a physical entity. You need to have an understanding of energy fundamentals to be able to form an opinion on what you see. And of course, when you see people who haven't spent an awful lot of time in school, they would look at what we call the correlation myth. They would take a multiple variable equation, and they would do correlation between the output and one of the variables. And that would show that that particular variable, out of a myriad of variables, is correlated with a certain output. Cherry picking, this is called data cherry picking, correlation cherry picking, right? And they would show, for example, that yes, as carbon dioxide goes up, the intensity of hurricanes is going up, which is, even that particular assumption is not correct. The NOAA, they have made public data available, which dismantles the whole concept. But nevertheless, a lot of people would look at an independent variable in a complex equation, and they would automatically assume that the correlation between that and an outcome automatically means causation. Now, this is something that we learn in Statistics 101 in business school, that correlation never implies causation. And you never do univariable analysis in a multiple variable equation, unless you want to massage the data to substantiate or to prove a particular outcome, which is something, again, you are taught in Statistics 101, that you never massage data. The data should be tall and standing tall by itself without having to be propped on either side. So going back to your original question about when and in what particular format these two conflicting opinions can come together, I would say not on social media, but in long format discussions, public discussions like this particular podcast, where you have the time to explain things from a technical standpoint, from a rational and pragmatic approach to solving a problem. This issue of energy transition is the most complex phenomenon, the most complex problem humanity is confronted with by a wide margin. It cannot be sorted out by ideologists or by people driven by ideology and wild dreams, especially because it has the potential of changing the lives and our society as we know it, and not necessarily for the better. So we have to be really, really careful when we think about turning the global economy upside down, and we have to be careful what we put in place.
Right.
So I'm a full believer in the power of the word and the power of explanation. And one of the reasons I started to be much more involved in explaining and talking and substantiating the points of views of our industry, which I think is a sound point of view, very pragmatic, taking into account the myriad complications of this phenomenon. I think it's the way to go. And we need, in my humble opinion, we need more voices to be vocal about the reality of what we are seeing and to be able to explain the difference between myths and reality.
Yeah, and also those kind of things where throwing ink or paint on art, those kind of things that are happening, and they get so much media and attention. So the same media could well bring more open debates to get bring in more clarity, right? I mean, this is
I mean, everything in life, or almost everything, can be displayed on a bell curve, right? And the bell curve has tail ends, both on the left and on the right. Unfortunately, most of these protesters, as I said, people who have spent less time in school than Greta Thunberg, would unfortunately be placed on the left side of the bell curve distribution when it comes to intelligence, when it comes to the power of understanding of things. And of course, people do stupid things from time to time, like throwing paint on artworks, like gluing themselves to emergency lanes, blocking access to hospitals, blocking access into business facilities, etc. I mean, there is people are capable of absolutely amazing things and appalling things. And unfortunately, when it comes to protesting against the evils of the energy world, we see a large spectrum of individuals coming forward.
well, Adrian, why is it that people like you don't get to address the United Nations like how Greta Thunberg, right? You mentioned gets invited or gets an opportunity to speak to a larger influencing audience, right? The policymakers, and also gets so much of media. So it's quite amazing. How is it that it is? Believe me when I say this, that even in small towns in India who don't perhaps speak as much English have heard Greta Thunberg.
Yes, no, I fully agree. It's a complicated question. I think the answer goes down quite a deep rabbit hole. In my view, the United Nations is dominated by the developed world, which, for a number of reasons, has embraced this entire green revolution of sorts, inspired by the Democrats in America, inspired by, heavily influenced by the Green parties in Europe, especially in Germany. And that has swayed the public opinion and the format of UN assemblies quite heavily towards one side. We have to remember that nuclear energy is not an approved source of energy for the United Nations. The UN is fully banking on renewable energy, and they perceive nuclear energy as being dangerous, being causing a lot of harm to the environment, which of course is absolutely false. So it's having people from the energy world speaking at such events goes against the grain of the current structure of these sort of events.
But the general argument is that your industry lobby is so strong. So if it is so strong, why are you not able to break through that? I mean, that's the general perception, right? That people say that it's all oil and gas lobby and all these protesters talk about it, but you actually don't get the podium to talk about it. So isn't
No,
it?
we don't. And actually, the so-called lobby of the oil industry is not that powerful. And you have to understand one fundamental thing. The narrative that is changing the world is coming from the way the large corporations are managed, right? So the large corporations are always managed by their board of directors. The board of directors is influenced by the majority shareholders, who are the majority shareholders of, let's say, S&P 500? Now, 88% of the shares in S&P 500 are owned by three entities. Who are those entities? Vanguard and BlackRock, because Vanguard also owns BlackRock now, and State Street, right? 88% of
Rather, they
S&P
have a
500.
little cross-holding, right? BlackRock holds some amount of Vanguard, Vanguard holds some amount of BlackRock.
I think now Vanguard owns BlackRock.
Okay.
Yeah, I think so.
Okay. I was thinking both of them hold each other, so okay.
Yeah, but regardless, you have,
right. Yeah.
88% of the S&P 500, which includes the leading American companies that are involved in energy, government contractors, you name it, are owned by three companies. And those companies together, they have tens of trillions of dollars of assets. That is a tremendous power. So here we're not talking about money anymore. We're talking about power for the sake of power. If you're Larry Fink, whether you make $10 more billion doesn't make any difference. And when you can influence, and the reason I'm bringing this into discussion is that the entire concept of ESG score is coming from Vanguard, right? It was actually, for BlackRock, it was Larry Fink who was the most prominent proponent of ESG scores. And this is how you influence the corporate world, by controlling their access to finance and by controlling the cost of finance. And of course, when you own the majority shareholding structure in a corporation, you dictate the president of the board, you replace directors, you replace presidents, and you can shape the way these companies work to your liking.
But is there a way to challenge ESG? I think it is very much a done thing. There is no way to even question ESG today, right? I mean, it's become one of the fundamental pillars, if you will, of a corporate entity globally today. It's becoming so strong even in India. In fact, that is becoming the benchmark to approach.
It is a very powerful thing. And the reason it's a very powerful thing is that it's pushed by very, very powerful people. I think the way to challenge it is not down to the businesses, although in some cases, yes, you can challenge it. But
at the same time, not everything of ESG is bad, right? A lot of what ESG propagates is actually a very logical thing as well from a sustainability of building a organization in the long term also, right?
I would heavily question the assumptions that are built into both the E and the S of the ESG. Elon Musk was famous for saying that the S in ESG stands for Satan, right?
Right.
Now, when you see a company like Tesla having an abysmal ESG score, and you see a company like General Motors or Chevron having a 4 times higher ESG score than Tesla, that undermines the whole concept of ESG, because it shows the degree of political bias that is built into the whole process.
Right.
So I'm not saying, look, I'm not saying caring about the environment is not good. I'm not saying trying to set up a business in a way that future generations can also enjoy it is bad. I'm saying that the instrumentalization of such a process to favor a particular industry based on the personal likes or dislikes of the people who are in charge of administering this is very wrong. If you want, if we can make a parallel to what's going in the artificial intelligence world, it's a similar danger to that of having heavily curated generative AI. For all of us who are using ChatGPT, we know how heavily curated ChatGPT is. Imagine a world where everything relies on generative AI to help people in their decision-making process, in optimizing things, etc. And that instrument, which somehow has become the golden standard for helping people do things better, faster, more efficiently, etc., is heavily curated in a way that you have no knowledge of, no control of, and no power to change. Both are equally dangerous. And while there is quite a lot of talking about the potential hidden dangers of generative AI, and we see attempts, especially in the American Congress, to regulate AI and to try and open up this black box type of thing that has the potential of dictating how we think and how we behave in the future, there is no concerned action to regulate ESG.
Right, very interesting, Bharapan. Right. So, last question I wanted to ask is that when do you see we will have a very dependable, sustainable, renewable energy source and battery technology?
On battery technology, I think we've briefly discussed about it. I don't see any technological breakthrough at the horizon that is likely to give me a good feeling about.
We talked about it in the present, but when do you see in future? Do you see sometime? I mean, I'm sure a lot of people. I think perhaps your company is also working on it. So a lot of them are working on it. So when do you see this can come about?
I would be more optimistic about a breakthrough in nuclear technology than a breakthrough in battery storage. For battery storage, we have, I think we've touched upon that as well. We have the Embry battery, the liquid metal battery that was invented by Professor Sadoway. So that is a potential breakthrough in static grid level storage. And if we manage to get that at scale, it could have a potential impact on the way we store electricity at grid level, which would ease the burden on lithium technology, and we could appropriate lithium reserves for electric mobility. As we mentioned in the previous points of our discussion, lithium, although seems to be a fairly abundant material, it's not that abundant. If we're to go full scale into electric mobility, and if we're going to go full scale or almost significantly scaling up our grid storage, the lithium reserves are going to be exhausted fairly soon. And the recycling technology of lithium-ion batteries is in its infancy. It's pretty complicated to recycle. You know, most of the lithium content is not in the electrolyte, is in the electrodes, it's in the cathode of the battery. And because of the chemical processes that occur, it's not a simple process to get to extract the useful lithium that has been interwoven in the crystal structure of the cobalt or aluminum phosphate electrodes. It's a complicated process. It's messy. It uses a lot of energy. So I'm hopeful to see the embryonic version of real ignition in nuclear fusion in my lifetime. Real ignition, not what was portrayed as ignition by the press, with the event that occurred at National Initial Laboratory in the US, Lawrence Livermore, because that wasn't ignition. I mean, it was ignition. Yes, we managed to ignite a pellet of fuel using lasers, and that pellet of fuel produced more energy than the energy input into the pellet of fuel. But the lasers have a 3% thermal efficiency. So the rest of the 97% of the energy that was used to create those laser beams was not accounted for. It's just a matter of where you draw the boundary around the phenomenon that you're studying. And if you draw the boundary right around the pellet of fuel, you would say, yes, the amount of energy that was going into the pellet of fuel compared to the amount of energy that's coming out of that pellet of fuel is more than one. Therefore, we achieved ignition. But if you factor in the amount of energy that you need to generate all those lasers, then you understand why that alternative is not viable. But I have hopes that the ITER project in France is going to yield some interesting results that could be used to make the first pilot test. Yes, so I was saying that I'm hopeful that the ITER project, the largest tokamak project in the world that we're building in the southern France, will yield some interesting results that would be used in the building of the first pilot test, the first nuclear fusion reactor, that will be probably the last intermediate step between the technology at the development stage we are at today and having the first commercial useful nuclear fusion reactor. And I hope I would see as I said, the early signs of that during my lifetime. But it's a question mark. It's a monumental technological challenge.
Well, Adrian, I'm sure we're going to have some whole lot of questions and comments on that. I urge all our audience and listeners to follow Adrian. He speaks in many places and he keeps very actively participating as well, sharing his perspectives. So the links are there for you to follow. And Adrian, thank you so much for making time. And also,
thank you very much, Ninja.
Talking about what could potentially be a little controversial from a point of attracting a lot of brickbats from people, which is sometimes very shocking, the way they come and attack on things and people. So I really admire you making time to come and share what you did. And thank you so much once again.
Thank you very much. It was a pleasure talking to you, and I hope we'll have another session at some point in time in the future, and we'll cover some more interesting and challenging aspects of the fantastic energy world. Thank you very much.
Wonderful. Thank you so much. And for the audience and listeners, I hope you enjoyed it as much as I did. And please go ahead, share this around, share this across, and also follow Future Fast and do come back again. Thank you once again.
Thank you. Have a good one. Bye-bye.